Hi everyone, I am Uday Johar. I am DGCM panel flight instructor and I'm here to brief you about the basics of instrument flying from the ground up. So I'm going to teach you everything that is required to learn and fly instrument, only basics on the basis of the instruments and not VFR, and to build your skills from basics so that you are able to do that without having any issues with retention, without having any issues with mathematics or calculations required in instrument flying. Understand, you're not a mathematician, you are just a pilot. Let's begin. So today I'll begin with the basics of instrument flying, that is scanning pattern. Okay, so scanning pattern is basically how do we look at the instruments to maintain the given structures, to maintain the given parameters. So there are different types. For example, if I draw a cockpit, considering a glass cockpit, this is the artificial horizon. Here is the airspeed indicator. Here is the altimeter. This is bank angle indicator, and there is a skidder below it, which is known as turn coordinator. This dial shows horizontal situation and is known as horizontal situation indicator. Here is rate of climb or rate of descent, also known as vertical speed indicator. So to begin with, scanning pattern is basically how do we look at the instruments so that we can maintain our parameters. To understand that, there are of different type of scanning patterns. For example, I start with basic, which is T-scan. T looks something like this. So this is T-scan, in which we scan speed, attitude, altitude and direction. So we can even go like this: attitude, airspeed, attitude, altitude, attitude, direction. So this is T-scan. Next is radial scan. Now radial is bearing coming out from the station. So keeping our attitude indicator at the center, we scan attitude, airspeed, attitude, direction, attitude, altitude, attitude, bank angle. So this is known as radial scan. Moving forward is known as V scan. V looks something like this. So this is V scan, in which we'll scan for airspeed, direction and altitude. Now remember, you do not have to focus on any of the given or structured scanning pattern. You can always devise it from your own sense. So the aim of the scanning pattern is only to ensure that you're maintaining the proper parameters of the flight, which is the airspeed, which is the attitude, which is the altitude and direction. So you can devise it on your own and follow the same, just ensuring that you're maintaining the correct parameters. For example, if I don't want to look at the attitude, I can only look at the airspeed, bank angle and altitude. Now if I look at the airspeed, bank angle, altitude, that means I can initiate a turn. During the turn, I only need to see my airspeed, my bank angle and the altitude, so that my bank is constant, my altitude is constant, and always, of course, after one round I can always glance at the heading so that I know where I have to roll out. Similarly, considering V scan is basically airspeed, direction and altitude. Again the same case, if I am turning right, I can only see the speed, I can see the direction, I can see the altitude maintained. So this will help me maintain my parameters in a turn. Similarly, if I continue with T scan, which is one of my favorite scans because it helps me to look at each and every parameter, that is basically airspeed, attitude, airspeed, attitude, altitude, attitude, direction. This helps me in straight level, this helps me during a climb, this helps me during a descent. So basically this is master of all the scanning pattern which I have followed myself, but again I'll recollect that it is not mandatory to follow a particular scanning pattern. You can always devise on your own. Moving further ahead are rate turns. So what are rate turns? Rate is something which is divided by time or second is rate turn. So if we carry out a turn with X amount of angle of bank, and we turn with the rate of change of my heading by 3 degrees per second is rate 1 turn. So 3 degrees per second turn is rate 1 turn. Why do we carry out a rate 1 turn? Two reasons. Number one, it is a timed turn, so that ATC gives us enough separation from other aircraft, so that he knows that it will take us some X amount of time to reach a particular place or to turn a particular heading. The second reason is that rate turns are a gentle turn, and they help us in maintaining comfort of the passengers as well. Since the angle of bank required is not that much, so the comfort of passengers is also maintained. So considering rate turns, now how do we calculate? It is very difficult to calculate 3 degrees every second that we are turning. So instead of checking our direction, we calculate the angle of bank required for the turn. So angle of bank required is true airspeed divided by 10 plus 7, which will give us rate 1 turn. For example, if I am cruising with true airspeed of, let's say, 90 knots, so my angle of bank required will be 90 divided by 10 plus 7, which is around 16 degrees. Do you remember the bank angle indicator? So it shows 0, 10, 20, 30. For example, this is 10, this is 20. So 16 degrees will end up somewhere here. We have to maintain this angle of bank so that I am able to maintain a rate 1 turn. You remember, I told you that we are not a mathematician but a pilot. So it is very difficult for us to calculate the rate turn every time by dividing the task with 10 and adding 7 to it to carry out the angle of bank correction to get the angle of bank. So for that, to make our life easy, this is the HSI. So there is a fluid or the magenta liquid which flows out of the HSI as we are turning. So if it reaches at this point, which is this line, then it is already a rate 1 turn. If it crosses this line, there is an arrow mark showing that our heading is increasing faster than required, or in a case in which it is not even reaching this point, it means the angle of bank is shallower. So we need to bank more to reach rate 1. So this is about rate 1 turn. Moving ahead, we will learn what are radials. So radials are magnetic bearings coming out from a station. For example, if this is a VOR or a station, the bearings coming out from it are the radials. For example, if I consider this as north, this is 090 radial. This will be around 070 radial. So the heading or the bearing coming from the station is the radial, which is commonly known as QDR. And opposite of QDR, or if you subtract or add 180 degrees to QDR, we get QDM. So QDM will be QDR plus minus 180 degrees. Now considering this diagram, if I draw another radial somewhere here, for example, if suppose this is 270 and this is 260, if I draw an arc of 3 miles and subsequent arc of 5 miles, if I am moving away from the station, the distance between the radial at 3 miles is somewhat this. But if I am moving further away from the station, the distance between the radial is this, which is more than this. So as we go further away from the radial, the distance between each radial increases. Similarly, if I am coming towards the station, the distance between each radial will decrease. So this is about radial. I hope you understand what a radial means, and you should be very clear what is a radial, what is a bearing, and what is the opposite of radial, which is also known as QDM, or heading to fly to home to the station. So to sum up, I just briefed you about scanning pattern, the different type of scanning pattern required. I also briefed you about how you can devise your scanning pattern by your own self instead of adjusting or instead of sticking to any basic scanning pattern. Further, we learned what are rate 1 turns, why do we need rate 1 turns, how do we calculate the angle of bank required for the rate 1 turn, and how the HSI helps us in easing out the pain as well of calculating the angle of bank. Further, we learned about the radial, the QDM, the QDR, and how with increasing distance from the station, the distance between each radial increases and vice versa. Again, to sum up, I will not be giving you some different lectures about instrument flying. I'm just giving you the basics of instrument flying, which is required and you should know as a student pilot, and you should be confident enough to perform the same when you are in the flight next. Thank you.